Hello everyone, this is Dr. Webb. In the last video, we talked about some basic derivative rules, including that if you want to take the derivative of the sum of two functions, well, it's just the sum of the derivatives. In this video, we're going to start off thinking about what happens when you want to take the derivative of the product of two functions. So let's jump right into it. So let's say f of x and g of x are two differentiable functions, and we're going to think about taking their derivatives. So the derivative of f of x times g of x. So let's appeal to our definition of the derivative. So in this case, for the sake of saving space on the screen, we're going to be using h instead of delta x because h is a little bit narrower. But this is just plugging in f times g into the definition of the derivative. So it's going to be x plus h plugged in to f times g. So that's f of x plus h times g of x plus h minus f of x times g of x, all divided by h. And so remember, h here is thinking about the distance between x plus h and x. So h really is measuring a distance in x value. And so what can we do here? Well, there are two main tricks that mathematicians use over and over again. One of them is multiplying by 1, and we see that quite a bit when we're dealing with limits. But another one is adding 0 in a really creative way. And so this is an example where we're going to add 0 in a creative way. So this is what we're going to do. So in between the f of x plus h and the g of x plus h, we are adding in and subtracting out this factor f of x times g of f of x. And so this factor right there. And so we're subtracting it and then we're adding it back in. And so at the end, this really just equates to adding 0. But in doing this, we're going to think about, once we've subtracted this in and added it back in, we're going to break this up into 2 bits. So this factor we're adding in, we're breaking it apart into the 2 sides. And then we're noticing that on the left-hand side, both of these have a g of x plus h between them. And on the right-hand side, both of these terms have an f of x between them. And so we can use this to factor out each side individually. So once we factor this out, then we can break out on the left the g of x plus h. And so really what's happened here is start off with this term on the right. Notice that we have the g of x plus h into both of them, and then factored those out, and they come down as this g of x plus h term here. On the other side, we have f of x on both terms, and so we factor them out, and that's the f of x that's appearing out in front. Okay. So now that we have this, let's look at what we have. Well, on the left side term, we have f of x plus h minus f of x divided by h. Well, this is exactly the definition of f prime of x. On the right-hand side, we're taking the limit that includes g of x plus h minus g of x divided by h. And this is exactly the definition of the derivative of g. So g prime of x. Now we still have this g of x plus h, but we're taking the limit as h goes to 0. And since g of x is differentiable, as we saw, differentiable means that it's also continuous. And so that means we can just plug in 0 there. And so g of x plus h is going to go to g of x. And then last but not least, we have this f of x term. But the limit that it's inside of is in terms of h. There are no h's here. And so f of x is not affected by the limit at all. So it's just going to be f of x. So at the end of the day, this is going to equal, well, that limit is f prime of x times g of x plus f of x times the other part of the limit is going to g prime of x. And that is our quotient rule. So at the end of the day, the derivative of f of x times g of x is f prime of x g of x plus f of x times g prime of x. Notice that it is not just f prime of x times g prime of x. That is not correct at all. It is this broken, kind of scattered, f prime of x times g of x plus f of x times g prime of x. It is not just derivative of f times the derivative of g. That does not work in the slightest. Okay, so this is what's called the product rule, because it's telling us how to take the derivative of a product. So the fg equals f prime g plus fg prime. So let's apply this to the derivative of x squared. I know that we did the derivative of x squared before, but we can think about the derivative of x squared as being the derivative of x times x. And we know that I can set f of x to be x, g of x also to be x, and we know that the derivative of x by itself is 1. Y equals x is a line of slope 1, and so the derivative of x is 1. G prime of x is also 1. And so if we wanted to take the derivative of x times x, well, this would be f prime g plus fg prime. F prime is 1 times x plus f is x, g prime is 1, and so we end up with x plus x, which equals 2x. So this is exactly the same thing that we got using the limit definition for the derivative of x squared. So the product rule works. Okay, so we get, same as before, the derivative of x squared equals 2x. What if we wanted to do the derivative of x cubed? Well, how can we break this up into a product? Well, we can have it be the product of x squared times x. So our f function here can be x squared. Our g function can be x. The derivative of x squared, which we just see, is 2x. Derivative of g, as we've already used, is 1. And so the derivative of x cubed is going to be f prime g plus fg prime. So f prime is 2x, and so we have a 2x there, times g, which is just x, plus f, which is x squared, times g prime, which is just 1. And so this equals 2x squared plus x squared, which simplifies down to 3x squared. And so that's our derivative for x cubed. The derivative of x cubed is 3x squared. Let's go and do one higher power. What about the derivative of x to the fourth? Well, we can use the same idea as before. Break this down into x cubed times x. So our f function is x cubed. Our g function is x. F prime, we just figured out, is 3x squared. G prime is equal to 1. And so when we plug this in, f prime g plus fg prime, f prime is 3x squared times g gives me an x. plus f is x cubed, g is just 1. So I have 3x squared times x gives me 3x cubed plus another x cubed. I end up with 4x cubed. So the derivative of x to the fourth is 4x cubed. And if you notice, there is a pattern starting to emerge here. You know, the derivative of x squared, well, that power 2 comes down, and we end up with 2, and then the new power of x is just x to the first. So it's 2 times x to the first. When we take the derivative of x cubed, it's like that 3 comes down. We end up with 3, and then it's times x squared. So x squared is 1 less than x cubed. For x to the fourth, it's like the 4 comes down, and then it's times x cubed, which is 1 power less than x to the fourth. And so what it looks like here, we have, in general, if we're doing d dx of x to the n, what's this pattern look like? Well, the power comes down, and then times x to n to 1 smaller power. So it looks like the derivative of x to the n tends to be n times x to the n minus 1. Well, what if we do this with negative powers of x? So if you recall, in the last video we did the derivative of 1 over x, and we saw that it's equal to minus 1 over x squared. What if we did the derivative of 1 over x squared? So let's use the product rule again. And so we're going to think about this as being 1 over x times 1 over x. And so our f function and our g function are both 1 over x, and we know the derivative of that. It's minus 1 over x squared minus 1 over x squared. And so when we apply the product rule, f prime g plus fg prime, f prime is minus 1 over x squared times times g, which is 1 over x, plus f, which is 1 over x, times g prime, which is minus 1 over x squared. So in each of these, I have minus 1 over x squared times 1 over x. So I'm going to have minus 1 over x cubed plus another minus 1 over x cubed. And so we end up with minus 2 over x cubed. Okay. So the derivative of 1 over x squared equals minus 2 over x cubed. What about 1 over x cubed? Take the derivative of that. So, same idea. Let's think about it as being 1 over x squared times 1 over x. Well, so then this means that our first function is 1 over x squared. Second function is 1 over x. F prime, as we see before, minus 2 over x cubed. G prime, as we see from up here, minus 1 over x squared. And so product rule is f prime g plus fg prime. F prime is minus 2 over x cubed times g, which is 1 over x, plus f is 1 over x squared times g prime, which is minus 1 over x squared. And so putting these together, we get minus 2 over x to the fourth, and then minus 1 over x squared times minus 1 over x squared is going to be plus minus 1 over x to the fourth. And they combine together to be minus 3 over x to the fourth. And so the derivative of 1 over x cubed is equal to minus 3x to the fourth. And so for these negative powers of x, we see another pattern where it's almost as if the power on the bottom becomes a negative on top. So 1 over x, that's x to the minus 1. And then we have a minus 1 in the numerator for its derivative. 1 over x squared, we have x to the 2 in the bottom, and then we end up with a minus 2 in the numerator. 1 over x cubed, we have a minus 3 in the exponent in the bottom, and then we end up with a minus 3 in the numerator. And if you think about it, 1 over x is equal to x to the minus 1. And minus 1 over x squared is minus 1 times x to the minus 2. Derivative of 1 over x squared, well, we can think about that as being the derivative of x to the minus 2. And then minus 2 over x cubed, we can think about that as being minus 2 times x to the minus 3. And 1 over x cubed we can think as being x to the minus 3. And so its derivative is minus 3x to the 4th. And so same as before with the positive powers of x, we see this power coming down, and then our new power being 1 less. So minus 2 comes down, and then our new power is minus 3. Minus 3 comes down, and our new power is minus 4. Should be a minus 4 there. So if we continue this on, this would be d dx x to the minus n. Well, this same pattern is going to hold, and so our derivative of x to the minus n is the minus n is going to come down, and then we'll have x to the minus n, and then subtract 1 from that. So it would be minus n times x to the minus n minus 1. But then if we want to then move this into the denominator, it's going to be minus n over, well, I'm going to take the negative of minus n minus 1, and it's going to become x to the n plus 1. And so that's in fact what will happen if we keep working along this way. So the derivative of 1 over x to the n is equal to minus n over x to the n plus 1. And so this gives us what's called the power rule. So we haven't given a full complete proof, but we've given an idea on how you get there. And the idea is you just keep on working for this. And so at this point we've shown, given the idea that this is true anytime that n is an integer, n is either a positive whole number or a negative whole number. And the derivative of x to the n, well, that power comes down, and you have n, and then it's going to be x to the power that's 1 less. So x to the n minus 1. And so this is one of the most important rules, along with the product rule in taking derivatives, is this power rule and how you deal with x to some power. Okay, so let's finish this off looking at taking the derivative of this product of these two polynomials. So we could multiply these all out and get one big long polynomial, and then use the power rule in each part of that to do it. Or instead of multiplying it all out, we could just use the product rule. So let's do the product rule here. So we're taking the derivative of the product of these two polynomials. So the first polynomial is x squared plus 4x plus 5. The second polynomial is x cubed minus 2x. And I can take the derivative of each of these individually. So remember, the derivative of the sum is just the sum of the derivatives, so we can take the derivative piece by piece. So the derivative of x squared becomes 2x. The derivative of 4 times x, well, we keep the 4, and then the derivative of x is just 1. And then the derivative of 5, well, 5 is a constant, and the derivative of any constant is 0. So f prime is going to be 2x plus 4. G prime, so we have x cubed, so the derivative of x cubed is 3x squared, minus, same as before, we have minus 2 times x, so it's going to be minus 2 times the derivative of x is 1. And so this is just 3x squared minus 2. And so then applying the product rule is this is going to be equal to f prime g plus f g prime. So now we just plug these in. F prime is 2x plus 4 times g is x cubed minus 2x, plus f is x squared plus 4x plus 5, and g prime is 3x squared minus 2. And that right there gives us our derivative. And so, it's not all multiplied out. If we multiplied this out, we'd have, something like 6 terms, which is an awful lot. Instead, we can just use the product rule and do this, pretty quickly, piece by piece. And this is perfectly fine for what we're looking for. So that is all for this video. I will see you again soon.